Alrighty, welcome back to the stream. Welcome back once again to more Adventures in Game Dev! And I really don't have enough energy to do that, so we're just gonna be chill today. The music you're listening to, as always, is the lo-fi playlist from StreamBeats. As always, big thanks to StreamBeats for existing and giving me music I can use on my streams. Anyway. So, as I said, this is going to be kind of a low energy stream, which is bad because I'm going to be doing something fairly advanced, or at least trying to. So let me give the explanation for that one. So, about like 3 or 4 days ago, it was like a nice 65, 70. You know, it was hovering around then. It was pretty cold, actually. Like, it was 50 degrees a couple days ago. And, yesterday it spiked up to 80-ish. Today it's like 84. Tomorrow it's going to be like 90. Now, let me actually take a look at what the weather's supposed to be like. It's supposed to break in a day or two. Yeah, it's like 80, 82, 83. Then it's supposed to break tomorrow. Thunderstorm, go back down to 70s, then back up to 80s, then down to 60s, and 70s and 80s again next week. Okay, so I'm probably not going to be able to fix the thing until like Tuesday. Works, I guess. Anyway, so it got really hot yesterday. And, you know, when it becomes hot for the first time, you generally feel like you get that heat fatigue because it's a very sudden change from what you've been used to of like normal cool weather or cold weather, and you get to you gotta kind of like readjust your internal body, like run. You gotta make sure that you're running fine. And generally speaking, like I'm just the kind of person who immediately when the temperature changes, I take like a couple days to adjust. So air conditioner comes on. Now, I had to go driving yesterday. I had to drive for a couple hours, and found out about 5 or 10 minutes into the drive, a 2-hour drive, that my air conditioner was broken in my car. So I got to experience the fun time of driving for that lengthy period of time, with the windows rolled down until until a big traffic thing happened, and I had to stay in place for the entire time and not get any breeze at all. And just experience that lovely scenario of being in a hot car on a hot day that blows hot air at you if you try to turn the air conditioner on. Not fun. So then I came back the next day with the exact same air conditioner, thankfully no traffic, so I could at least keep the windows open a bit, but still, just awful. Get home, turn on the air conditioner because the house is very warm, and find out, oh, the house air conditioner also broken. So, in addition to that, I went outside like all morning today just trying to fix the thing, found out what was sort of wrong, maybe. There's a part we gotta order in that might fix it. But who knows, that might not even be the problem. It might be like a whole fucking air conditioner got replaced problem. And just if I don't know if it's coming through, but I got a fan blasting into my room, and unfortunately this room is also the worst one in the house for this. It is the least insulated house in the entire room because it's directly over the garage, which means it gets swelteringly hot in the summer and freezing cold in the winter because it just goes right through the floorboards. And it's also at the edge of the house, so there's like no circulation between any of the other rooms or anything. So if I want to get any air in here, I need to use a fan to just shove air in, because otherwise it just will not do anything. It'll just stagnate and it'll like, none of the air in here leaves ever. So it's just a terrible situation overall, and I'm hoping it'll get fixed relatively soon. And that's how my day is going. I'm stuck in a hot room on a hot day while my computer's chugging away, throwing out even more heat. Like it's miserable. Anyway, at least I got water. So, let's get back into this. Oh, right, before I do anything else, actually, let me go show off a little bit of what I did here. So, on the back end, I rewrote some code and just, like, compressed a couple things into functions and code instead of blocks. Makes it a little easier for me to parse it, just especially when I'm doing stuff with, like, the settings. I don't remember if I put these in last time, but resolution, window, and FPS settings are now in there. FPS settings actually do work. So it's chunky, but it is actually functioning properly. I converted all the code over to using delta time, which didn't really make too much of a change, honestly. Like, it did very little. Okay, let me see here. What was the last... What were my history change? What were my changes here? There we go. So version 1.10. Object selector changed my code base more efficient. Resolution settings present in main menu settings menu. Okay, so those were there. I removed a bunch of extraneous code from the selector object. I added delta time functions, ball speed, and paddle speed changed to run via delta time. Settings partially written code include FPS settings. So I had the FPS settings. If I go to scripts right here, I just create a new function called delt, and all that does is just converts like the frame rate, FPS target, into basically you plug a number into that, and it'll just convert the number into whatever the current frame rate's value is supposed to be in order to make it match. That's all it does. Just take your target delta, which is 1 over FPS target, actual delta time divided by 1 million, and then your delta multiplier is that, then return the delta multiplier times the number you put in there. And just as an example for that, object ball has a speed here of 10. That's only in 60 FPS though, so if I put it to delt 10, that converts it automatically between 30 and 120 FPS, depending on which one you're using. And the nice thing is, for any of those FPS things, I can just change it. I can change the FPS settings to whatever number I want. No problem in the least. Then over here, added regions, the step setting event, reduced delete redundant code. Ah, yes. Where is it? Objects, settings. So here, I converted this stuff to code, just because it makes it a lot easier for me to like go through here and just replace things if I need to. Like, instead of having to add new blocks and, like, move them into position, I can just take this and just copy things over and just literally copy-paste instead of having to deal with blocks. And what I just did there is I added these things called regions. So if you add number, region, and then text, that lets you basically shrink that entire thing down as if you're using, like... Because stuff like switch and if lets you do the same thing. Region lets you block out sections yourself to shrink them down yourself. So that's all I did there. Alright, and then finally over here, this is stuff I was doing last night when I was just futzing around with things. Modified script settings to have 2 additional scripts. There it is. 2 extra functions, settings read. So the one I was using before is, you got settings read, settings write, and there was a third one here, wasn't there? No, I guess that was it. So basically, wait. Yeah, there was one, wasn't there? Settings default. Where did I put settings default? But why isn't it present? Hold on, something's weird there. That's really weird. It should be calling. I thought it was here. Settings default should be there. Okay, hold on, something's weird. Settings default is there somewhere. Anyway, this is just supposed to be a quick thing where I can just, like, read the settings off, and then this one's just, like, a quick thing to just write the settings so I can adjust stuff from here instead of having to go to wherever else. So as an example right here, in the room game, when I'm using the menu stuff, I could just, instead of having blocks of just like, write the code, fill in the code, I just do settings right, and it just writes all the information I need based on the script that I have over here, so I don't need to write everything out. It makes it much more streamlined. That's weird, though. Okay, I've got a thing here, actually, that shows me what I've got. That's convenient. I don't want that one. I want script settings. That's the one I want. Function settings default. Oh, wait, what? It is here. I'm not seeing it. Freeze. Right. Weird. Wait, why was I not seeing it? What the fuck? Why? What? Wait, something's really weird here. It should, like, it literally should be here, but it's not. What the hell? Okay, I'm gonna go back to source control here. Okay, I'm just gonna copy this over. Thankfully I can do that easily, but why isn't it showing up? This is really weird. Like, there you go. That's all I needed to do. But why? I bet I know what the problem is. Hold on, let me disable that for a second, and I'm gonna go and delete the IronI file. This because I think what's happening is for some reason I deleted that, but I still had the IronI file in my files, which is why it didn't break. Yeah, that's what I thought. So I don't know why it disappeared, but it should have been in there the entire time, but now it's back, so that's fine. Now it's back, so it's perfectly fine. Good. I don't know why it disappeared. That was weird. Okay, I'm just gonna give it the changes here. Stage all, fixed, missing. I don't know what happened. Thank God for version control. I literally just had to open up a small window and it just told me, oh yeah, this is what changed. I went, why? Why is that gone? And that's why version control is important. Anyway, let's return to what it is I wanted to do before I ran into some weird technical issues. So that goes through all the changes I made, you know, over time here. Extraneous, dealt function, setting step event, changed, modified the script settings to have 2 extra functions, setting read settings right. Function for resolution and screen resolution is now game resolution, provide name conflict. Oh yeah, that's the other thing I did. So just this function is now called game resolution, and I just call that elsewhere, which is really only in the initialization object, because I don't want to call things script resolution because that might call this thing and also might call the function. Or more accurately, it calls the entire script, so if I had multiple functions in there, it would do those. Don't want to do that. Right. So, what we're going to be doing today is we're going to be trying to look at shaders. And the reason why is because I saw this video.
With video games,
Hold on a second, let me pull the video up. Alright, here you are. Alright, so, this video here, I'm just gonna mute it because I don't want to talk over it, caught my attention because, like, it looked neat, right? It's just talking about, like, when you have pixel art stuff, you have to usually draw the sprites out, and then normally, you'll show in a second, when you do sprites for things, you have to have multiple sprite sheets for multiple different variations of the character. So if you change clothes, you need to have one set for each thing, right? And then here he talks about how, generally speaking, the problem in like other 2D rigging that isn't sprite art is not a problem, because what's moving are these parts, and then those are just attached to these images. Their animation and appearance are decoupled. And he's going, okay, what about if we did that in 2D sprites? How do we do that? And he goes on to show here, what he actually does is like there's each pixel here has an RGB value and an alpha value. And then you can use those. Those are just numbers, right? These can also be an X and a Y coordinate. So it does this. Urge can be X, Y, and just move those around, right? Which gives you an X coordinate here based on the number value of a square, and then you can get like the color of that thing from wherever. I believe this is how like an atlas works, where you have color lookup texture. Like this is what he's talking about here.
In any way I want. And all I need to change its color is to modify this one lookup texture on the right. If we apply this idea to the walking animation from before, we end up with something like this.
Yeah, so basically here you have a source image which is weird colors, and then each of those colors correlates to a specific part here on the lookup texture, and then that translates into this, which is done by using shaders that basically pull the data, pull it over, and then change what the color is. So you can change the colors here, and then he shows an example here of like if you just take a paint bucket and just, or brush and just do that, it shows it there, right? That's a really good idea. I was thinking like, you know what? Why not try and do that myself? Now this is going to be much trickier because I'm going to have to try and learn how to do shaders as well while I'm working on this. But that's basically the idea I was working with and what kind of drove me to try doing shader stuff now, despite it being fairly advanced. Anyway, let's give that a shot, shall we? So this is the guide I'm going to be using here. You can just find that in the YoYo Games manual or whatever. Right. So what is a shader? They're created to provide shading for lighting, hence the name, but now they're used to produce a huge variety of effects. Shaded code is similar to regular code, but it's almost always executed by the GPU instead of the CPU. Each shader is made up of two separate components, a vertex shader and a fragment shader. Actually, you know what, let me just, there you go. Let's see. It's probably formed by a rectangle, but computers like to draw triangles, so those rectangles are split into two triangles, sometimes called a quad, and then they have examples here. Vertexes here, and then these two are counted twice, so you don't really have to worry about those since they overlap. For a fragment shader, you can imagine the same loop as before, but this time it goes over every single pixel in your sprite. Alright, so for vertex shaders, you go this, whatnot. For a fragment shader, you can imagine the same loop as before, but this time goes over every single pixel in your sprite, giving you information such as location and color of that pixel, which is the information you want for the lookup texture. In your fragment shader code, you perform operations and calculations to determine the color of that pixel to get the effect you want. For example, if you want a shader to make your sprite be black and white, then you calculate which shade of gray each pixel needs to be to create the effect. It will look something like this. So wait for it to reload. So it'll go line by line until it hits a color, and then it would sort of normalize the colors to be whatever you want. The reason shader code is usually executed by the GPU is that it's more efficient at it. Modern CPUs typically have between 2 to 8 cores. Each core can perform one task at a time, so by taking advantage of multiple cores, we can perform many tasks simultaneously. Yada yada yada, that's stuff for that. GameMaker allows the website in the OpenGL shader language, high-level shader language, and subset GSL, which is GLSL, which is common in mobile devices. We're using GLSL ES as the share language. It's the one that provides the best compatibility across target platforms, the one you want to always use unless you specific needs and understand limitations. Alright, well, I'm just going to basically copy and paste whatever's going on here to try and figure out what I have to do, so that's not too big of an issue. Vertex shares execute first. It deals with vertices. Shares not particularly useful in 2D since every sprite is usually square, but can be used to do some skewing, scaling, etc. Becomes more useful in 3D for lighting calculations and mesh deformations. So shader variables. Create a shader in GameMaker. You might have noticed the following keywords in the default pass-through shader. Okay, so let's turn this off for a second here, and let's create a new shader. So let's go shader test, just so I have it there. So I got this is the vector or vertex, and this is the frag shader. Oops, wrong button. Let's see here. Keywords can help understand the shader purpose and scope. Attribute. These variables are passed in OpenGL to the vertex shader. It can change per vertex and are read-only. Vertex position, texture, coordinates, vertex color, and vertex normal. Varying these are variables used to pass data between the vertex fragment shaders. You have uniform. Also use of vec as a keyword. Used to identify a vector variable in the shader, and you'll soon see that vectors are very important when working with shaders. Math filter, yeah. This is all stuff for that. Oh, I need to actually read this. So, vec first vec is two-directional vector of floats. The attribute vec3 in position, 3 in normal, in color and texture chord. Oh boy, I may have jumped too deep in, but we're gonna plug through. We're gonna keep going. Accessing vector components GLSL. Okay, wait. So vec vec2 means a 2D vector. Vec4 is a 4D vector. Vec3 is a 3D vector. Okay, that makes sense. Using 2 scalars and a vec2 create 4 values. So it would be... So, okay. Vec2 is a 2D vector right there. Vec4 is a 4D vector. I input 1 value there, then it does first vec for middle 2, and then that for the third one. Third vec is a 3D vector, which does a single component of the 4D vector plus vector 1, the first vector here, to give you 1, 2, 1 from this one here. You can treat the vector like an array and just pull out vector 0, 1, 2, 3, or if you use x, y. X, Y, Z, and W to get them. Oh, and this is interesting. So here you can actually take... You can actually pull just all the things right at the very end there. So second vec is first vector XYZ, which is just the first 3 vectors from this. Then third vector is second vector ZY, which is just the last 2, but in reverse order. And then fourth vec is third vector, which is second... So it would be... Y, XXY, so it'd be Y, Z, Z, Y, where Z is Z and Y from here, and those are from first vec. Like, that's... Okay, interesting. That's, it's weird that you can do those transformations. I feel like there's easier ways to do that, but it's okay. Sure. Up to 4 letters. Okay, now when you're setting up myvec here, you can't do myvec.xx because that would be myvec x is 2, 3, and then myvec x is 2, 3, so that wouldn't work. I guess. Usually the case in dealing with positions, there are 2 more sets of maps. You can use RGBA and STPQ, used for texture coordinates. Can't combine swizzle masks in the same operation, so it has to be XYZW, RGBA, or STPQ. I don't know what STPQ means. Alright, that's actually not too bad. So basically it's just, these are the lengths of the vectors up to 4, 2 to 4. You can't have a one-dimensional vector. You can change around the stuff to transform vectors in however you want. You can access them like an array, and you can use different types of lettering to notate different parts of the vector. Okay, so create a shader. When you create a shader, it will open 2 files for you. Vertex shader, and the other one, fractal shader, fragment shader. That's the one. Most basic shader you can make, which takes a sprite, reads the texture, and colors each pixel with that color. You specify vertex colors when drawing, those colors will blend with the texture. Let's go to the code for a newly created shader asset and analyze it, starting with the vertex shader, okay? Outside the main function, let's go with the vertex shader there. I'm just going to move this over a little bit. So outside the main function, we get some variable declarations and their qualifiers. The attributes are given to us by GameMaker. Varying ones are created by the user to pass the information over. First, we create vec4, initialize it with the components of the position, adding 1 is the fourth component, which is going to be your alpha, I guess. In linear algebra, convention is that we add 1 to the fourth component if the vector is representing a point, or 0 if it represents an actual vector. So I guess it would be 1 in this case? Oh, I see. It's over here. It's this part. Ah, I get it. So because it's representing a point instead of a vector, it's in position X, in position Y, in position Z, and then 1 to represent the point status of it. Okay? Next, we need to add this fourth component to multiply it with the matrix worldview projection matrix, which is a 4x4 matrix. Multiplication project the world position of the vertex into screen coordinates. That's stuff about 3D views I don't understand because I haven't even looked at 3D views at all, because that stuff is... I don't even know how to deal with that, really. Finally, we pass the vertex colors and texture coordinate to the fragment shader through our varying variables. So that would be this. Vector varying color is in color, text coordinates is texture coordinates. I guess. Shader should be left alone if you're not planning to play with vertex positions. It will not be used in any of the examples given below because all the effects shown will be created using the fragment shader. Take a quick look at the fragment shader now. Much simpler. Probably not much easier. Okay. Oh, so it actually does both. These two get passed over to the vertex shader. Okay. So every shader has this part and this part. Vertex shader happens first, and then it passes over to the fragment shader. Interesting. Okay, good to know. So I won't touch the other one for now then. As explained before, the idea behind a fragment shader is to return the color of the current pixel. This is done by assigning the variable glFragColor the file color value. Texture 2D function takes the texture, and in vec2 with the UV coordinates, you want to check in that texture, which returns a vec4 with the color. In the pass-through shader, all we're doing is grabbing the color of the texture and the coordinate of this pixel and multiplying it by the color of the vertex associated with this pixel, which is probably 1. Now, with our first shader, we have to do is create an object and assign a sprite, and then in the draw event of the object, to set the shader like this. Shader set, shader color overlay, draw self, shader reset. Okay, so let's go to room real quick. Let's open up the testing room. Where does it go? Create an object and assign a sprite, then the draw event. Okay. In the draw event, you set the shader like this. Okay, so copy that over. Shader color overlay is not valid, so shader test. Okay, so let me look up the shader set and shader reset functions here, and draw self. so shader just sets shader for the thing, and then it's draw self. What is draw self? Draw self. Draws the sprite assigned to the instance exactly as it would be drawn in the draw event, held in no code or action, and reflect the changes that have been made to the sprite variables and other events. And sprite shader reset. Okay, so that's just a it's kind of like a surface thing. You set the surface to be drawn, then you draw the application surface to it, and then you release the surface afterwards. Or what have you. That's basically what's going on there. Okay, every draw call we make between shader set and shader reset will have the shader applied to it. Okay, right. So draw things here will just constantly... So basically, if I got rid of shader reset, it would constantly draw with that shader. Here we're drawing the object with a pass-through shader. Might have guessed this does not visually change anything. It's a simple pass-through shader. However, the section below outlines some simple steps you can take to modify this and change the way the sprite will be drawn. Each of the sections shows a different shader that you can create and use in your projects, explaining the steps required to create them and why we're doing things the way we are. So let's try the color overlay shader first. Ooh, that's something, isn't it? Alright, so we can add the base shader now and do something different. We'll not be touching the vertex shader part, only editing the fragment shader. This will do a very simple operation, which is make the color draw the sprite using the color red. We'll do this by simply changing the GL frag color to be red, like this. So, vec for... just like that. So doing this should make the sprite a horrible red. Boy, is it! Yeah, look at that. Yeah, look at that. Okay, so... what would I do with this, then? Red, green. Yeah, that's it, alright. Alright, let me look at the RGB colors. Every sprite is ultimately rectangle, so unless you consider transparency, which we haven't, this is the result we'll get. Okay, yeah, so it's only changing because this sprite is like sort of changing size based on what's going on here, instead of being a pure square of that size or whatever. The rectangle changes size because the base sprite is the empty space around it cropped automatically when it was placed on the texture page by GameMaker. So each animation frame that triangles make over a different size to fit the cross size of the frame. Next texture 2D. We'll use that to grab the color at the pixel we're working on and get the transparency from it. Return value is texture 2D is a vec4. Or we can access the alpha channel by either putting period followed by an A or W to the variable name. To RGBA and XYZW respectively. Here's the updated code. Okay, so vec4 text color. Texture 2D function, which I don't know what that does. What's texture 2D? That's not the right... So it makes a reference there to texture 2D, but it doesn't tell me what that actually is. Okay. The texture 2D function takes a texture and a vec2 with the UV coordinates you want to check in that texture, which returns a vec4 with the color. So sample 2D is GM base texture, and vector 2, the vector is text coordinate. Texture coordinate. Texture coordinate is in texture coordinate. Text color, texture 2D, GM base texture. What is GM base texture? It's just shader constants. This is a 2D sampler constant that returns the texture of the current object as set by GameMaker. So it would be the current sprite, surface, or texture that would normally be used when drawing without the shader being called. Okay, so it is just, like, given the sprite I have for this is just a basic green block, that's all it's pulling. It's just pulling the basic green block. But if I go back to that video I was looking at, if I was doing that here, this is the base texture, right? And then it would be applying the shader to that, and I could do things with this, I think. Alright, anyway, so it's pulling that texture, it's pulling the coordinates, which I think are... I think that's actually like the location of the pixels and whatnot on the sprite. Here's updated code. Yeah, it's whatever. Oh, right, I need text color.a. Text color? Okay, wait, which? Text color.a. What's the text color? Oh, right, that's text color, right? Hey, look at that. Now it's the right size instead of being a rectangle. Look at that. Hey, see? Look at that. Aha! Now, the important thing to note here is... I can close this. I don't need that for the moment. Save that for the time being. This is supposed to be green and have, like, lighting and stuff. So it's not quite perfect. And it's also invisible now, which is weird. I don't know why it's invisible now. Alright, well that's something else to fix, I suppose. Back to this. Okay, we're now assigning a new vector 4 to GLFrag color. Where the red channel is maxed, the green and blue channels are 0, and the alpha channel is the same as the original texture. The output looks like this. That's what we're after, haha! We replaced the color of every pixel with red, but have kept the alpha channel intact. Mostly. Having to change the shader each time we want to use different color isn't a good idea, especially since we need to have a separate shader for each color we want. Instead, we will pass the color information to the shader using a uniform. To do this, we first need to get a pointer to the uniform. We'll do this in the creative end of our object as the sprite by adding those variables. go. All we need to do is call shader_get_uniform, which does what? Shader.uniform. Since you cannot change the value of your shader constant within the shader itself, you have to set it before calling the shader using one of the very available uniform set functions. However, you'll be able to do that. To be able to do that, you must first call this function to get the handle of the shader constant that you want to change. Shader_get_uniform, shader_uniform. And next to the shader to use, uniform, shader constant to get the handle of, a string. This is uColor. Yeah, so there's different ones of those. UV refract color or whatever. Shader parameters. All we need to do is call shader_get_uniform to get a pointer to the uniform. The parameters we need to pass are the shader asset name, without connotation, because we want to pass the ID that the thing GameMaker generates for us, and the name of the uniform variable inside the shader, which is this. This time it's a string. This name needs to match exactly the one inside the shader code for it to work. We also have added a color variable, so we can change it at runtime and have it remember our changes. Now the code in our draw event will change slightly to pass the uniform variable. Shader set uniform f array, unicolor color. Shader set uniform f array from unicolor, which is this thing, and then color, which is that. Is that going to draw it red or yellow? Draws it yellow. Because I set it to yellow there. Maybe. Okay, it's the shame color. Same code as before, but before we draw anything, we need to pass all the uniform values to the shader. In this case, we're passing the color as an array of floats. As for the shader, we'll change it to become the uniform and use it so it becomes. Okay, so varying vec. This is the same. This is the same. Void main. Tax color, texture 2D, GM base texture, V text chord. Back for uColor RGB, text color A. And that should give me yellow, actually, which is amusingly what the, huh? uColor RGB constructor, fragment shader, string not found at line 1, computer failed with next to 1. Is uColor not a shader variable? Or shader constant? Shader constant. So I got compile errors over here. Now, why am I getting these compile errors? Same. Oh, God, you know why? It's because it's not consistent. Is that how you spell color? Hold on. I've lost all sense of spelling now because of this. Okay, yeah, that is how you spell color. Good. Ugh. Because this one's spelled U-color with a U, and this one's spelled U-color normally. That's why. Is that supposed to be you? Is it a British thing? No. RGB constructor. Oh God, I hate the British. Why do they do this? Everything's got the fucking U. Where's U color's vector coming from? Where's the vector for U color coming from? Okay, this is the sprite. This is the fucking okay. Great event. Draw event. Finally in the shader. Okay, that one works. Now it's black as well. It's weird. Oh, because U color was added here. God, that's why. So why is it black? I missed this part. That's why. That's why I wasn't working. So I guess I'd go here and then like change this to be, I don't know, 0.5. Something like that. Then what does that look like? Nothing. Straight up black. I don't know why. Do I have a camera in that room? Yeah, I got a viewport. It's in there. Not on. Okay, why isn't it working? I'm just gonna work my way down. I'm just gonna copy everything down. And it's still black. What the fuck? Why? Why is that black still? Has to be something with text color because it's not RGB. Do I do 1? No, that's not it. Why isn't it working though? Why is it black all of a sudden? Okay, so it's something there. So whatever's going on with UColor, it's not properly putting in like the stuff I need. Uniform vector is UColor. It's not this, is it? I bet it's that. I bet it's that. It was that. That's what it was. Because the stupid U! The U was the problem! So it's not that means that what shader get uniform is doing isn't it's not getting the uniform, it's setting it. Whatever that's doing, it's setting it as UColor or something. I don't, or rather it gets this vector, which get into unicolor, and then color there, and then shader set uniform F array. Just there. What does set uniform F array? What does that do? What does this do? Let's go to this one. There it is. Okay, so all uniforms must be set after calling the function shader set and before calling shader reset. Handle array. Unicolor and color. Nice. Oh, okay. I see. Okay, so shader get uniform. Pulls index of the shader constant to get the handle of. So you get a shader constant. You pull that into unicolor. Unicolor stores that variable, and then shader set uniform F array uses unicolor to reset it, and then add the color values that you put in there. So because I had color and color here, it was actually setting it to the wrong... It was setting it to a different constant, effectively. This would be easier if the person writing it wasn't British. Or at least was consistent. Like right here, this is not consistent. Color, you color, which... Make up your goddamn mind! It's too hot for this. Alright, anyway, shader. I now have a color overlay shader. I vaguely understand how it works. Very vaguely. God, it's so hot. It's not actually that hot, but it's uncomfortable. Like, it's 80 degrees outside right now, and I'm feeling it in my room. It's uncomfortable. It's not like sweat and buckets and tears. It's just like, let's try the next one, black and white shader. Making black and white shader is a great way to learn more about how shaders work and allow beginners start by trying to do this. Since conceptually it's quite simple. Get every pixel and assign it a shade of gray, but is that simple? Not quite. When using RGB color, if all three components are the same value, they will get a gray tone. The naive approach to creating a shader to use this idea would be to add all three color channels, red, green, blue, and then divide it by 3. That you'd assign the value to all three channels, thus creating a gray tone. Let's see. So, blah, 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 blah. Well, let's do this. Make a new one here, and I'll just block out this one. There you go. Now I got all that stuff in there, and I don't need to... I can just rip it apart as I need without having to look back up. One thing you might notice is that the GL frag color code, we're multiplying the vec for something called VV color. It's a variable passed by the vertex shader, which tells the color of the vertex associated with this pixel. Always a good idea to multiply your final calculated color with the vertex color. In most cases, it won't do anything, but if you change the vertex color in GML, this reflect that and by using functions such as draw sprite external or draw sprite general to change the image blend. Alright, so just do this, draw event. This is a color overlay. Okay, so this is just setting the thing, drawing it, that's, you know, whatever. As for this part, yeah, the Vec2, Vec4, this is the same, but instead of uniform there, we have varying Vec4. I actually could have kept there if I wanted. Vec4 text color, texture 2D, GM-based texture. I think this is the... Yeah, it's the same here, pretty much. Actually, it is the same. But instead of having frag color be the Vec4 or the RGB plus alpha, we have text color gray. The gray vector is text color RGB divided by 3. What was text color? Oh, right, text color's right there. Text color is just the... Yeah, right. Okay, float gray. And then The frag color V is spec 4 gray, 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 text color dot A. It's kind of hard to make out, but it is slightly darker. Like, it is gray scale. It's hard to make out, though. Let's change the sprite on that, actually. Okay, I'll do this one. Yeah, look. Grayscale! Woo! Hard to make out when there's not much difference. Let me see. Can I get, like... Maybe Humble has some, like, wacky sprites or something I bought at one point. Okay, so let me just take a look at my purchases here real quick. Okay, you know what? I got a better idea. Is this Spelunky 1 or 2? I think this is Spelunky 1. Now, if I remember correctly, Spelunky 1 is open source. And either way, I can just borrow... Okay, you know what? Let me just do... better sprite. The original Spelunky is open source. I'm trying to find a good image for this. You know, let me just upload a new image. Got some memes. Would be good. Here, have a sprite. I'm gonna upload a new sprite. Here, let's just throw this in here. Can I literally just throw it in here? Yes, I can. There we are. There we go. Look at that sprite. Oh shit, that's grayscale, isn't it? Yeah, I don't want to use this one. It's already grayscale, and that's not useful. So let me just take that one. I've got another image in here I can pull in. Here, try this one. Look at that. Plenty of color. Lots of color there. It's gonna look terrible shrunk down, but it works. So anyway, let's just go with that. I'll just use the Balor. Alright, now we'll go to Object Test. So let's take a look at what it's gonna look like. Oh, jeez, it's huge. Okay, it's fine though. Check it out. Hey, look, it's grayscale. Yeah. That's the important thing. Doesn't look great, but it works. Alright, compile, see what we get. Looks great already. Rel, yes and no. The solution that's more correct. So instead of adding the components and dividing by 3, multiply each component by the standard NTSC values for black and white. Here's the modified fragment shader code. See black and white fragment shader. Go back to the shader. Okay, so instead of before, where the shader had the V color here, and let's see, void main, text color, texture 2D, gene base texture, yeah, same as before. Float gray is dot product. Really? So dot product of the RGB thing from text color with the vector, these specific vector values. And then gray color is vector 4, gray text color A. Here he is, okay. Dot product is shorthand for multiplying each component of the text color with the correct weights and then adding them together. If you're unfamiliar with the dot product, this is essentially what's happening. Yeah, dot product is basically just first part of the variable, first part of the vector multiplies the first part, second part, third part, third part. That's all it is. By the end, it looks very similar, but it's technically more correct. I didn't think there was that much of a difference, but okay, whatever. Alright, so third part now, rainbow shaders. The final shader is a fun one and can be used to add life to text and buttons and other things. We'll start simple and add functionality gradually. Oh my god, this is huge. This is very big. Oh, I see, because you have to start randomizing things and then clamping them. Oh god. Lots to cover, so if you feel a bit lost or confused, please go back and reread some of the sections above. Yeah, I probably will have to. Okay. Finally, blah, blah, blah. First thing we want to do is color pixels with every hue depending on the pixel's horizontal position. The way to do this is to set the X position to be the hue and then convert from HSV, hue, saturation, brightness, format to RGB, red, green, and blue format. For this, we'll need to write a helper function in our fragment shader that takes HSV values and returns an RGB vector. We'll use a single function which does this without the need for any if statements, as using conditionals in shader code makes the shaders very slow and should be avoided. That makes sense. Here's what it looks like. So, in the shader, we have varying, same as before. Vector 3, HSV to RGB. Vec 4K. So Vec 4K is equal to Vec 4 of 1, 2 divided by 3, 1 divided by 3, and 3. Vec 3P is absolute of the fract. What's fract? N is the fractional part. So if you have free 1.25, it'll only return 1.25, which is interesting. I guess that's useful if you're like scaling things up. So instead of getting the whole number and then having to convert that to like rotations or whatever, you just get the fraction that just tells you how far around. Like I can see that being useful. When I was doing stuff with Adobe, for example, there was a bunch of knobs effectively, and every knob rotation is like one movement over. But if you're doing like an actual rotation, once you hit 360, it doesn't matter anymore. It doesn't matter if you rotate it like 5 times, you're still getting like the same position. It only matters if you're doing like a specific change over time, where you have to count the number of rotations, which, you know, that's probably fine in that case. Just one thing it is. So that's, I don't think this is correct though. I think it's supposed to be frac, not fract. So the vector C dot xxx plus kxyz times 6 minus kwww. Return C dot z times mix. What the hell's mix? What the hell are mix and fract? Void main, vec3, yeah, okay. Call is that. Float alpha texture 2D dot A. This is incorrect, that should be in there. Wait, yes, yeah, it should be in there. God, this typo's all over the place. Is it? No, I actually shouldn't. Because the alpha is only coming from... Right, the alpha... That is actually correct. This is giving me a 4D vector. Is it 4D vector? Hold on. Yeah, it's giving me a 4D vector, and I'm just pulling out the final bit of that, which is the alpha. That makes sense. Frag color, v.vv color. Yeah, okay. Takes this thing, transforms it based on this stuff here, And then alpha, which is the alpha from this thing. Vec4, V color. Okay, yeah, sure. First, there is the HSV to RGB function, which takes a vec3 with our HSV color and returns another vec3 with our RGB conversion. And the main function, we start by creating our HSV color, where the hue is our X position, and we'll leave the saturation of brightness as 1.0 for now. Then we get the alpha from the texture, so it only colors our sprite character, not the entire sprite rectangle, as we did in the color overlay example. Yeah, okay. Last, we saw our fragment color be our HSV color converted to RGB with the alpha multiplied by the vertex color, which is good practice. And then the draw code. Cool. So it's not changing a whole lot because it is a static image, but if I had the sprite that actually moved, it'd probably change. Nice. We're close to what we want. Well, there's an issue. We're not seeing all the colors at once in every frame of the animation. The colors seem to change randomly. The reason that we assume that V text scoring gave us the coordinates of the sprite starting at the top left corner, ending with the bottom right corner, which is standard in shaders. However, for optimization, GameMaker stuffs as many textures together as it can fit in what's called a texture page, and because of that, this is how our texture actually looks. Ah, right. Okay, I see. So because this texture is technically this entire thing, this is like the start of it, and then it goes down to here, which is where the last colors be. I see. V texture coordinate gives us the absolute coordinates of the sprite within this entire texture page. Oh, it didn't explain that, actually. I don't think it actually told me that. It definitely did not tell me that. It absolutely did not tell me that. I did not know that. That's the first time it's told me that. V_V text coord is the absolute coordinates of the sprite within this entire texture page. What we want is a value from 0 to 1 that only covers our current sprite. Process called normalizing, big value translating from 0 to 1 range. To normalize our horizontal values, we need to know the values of 0 and 1 in the picture above, which is here. Luckily, our GameMaker is a function that gives us the location of every corner in our sprite within the texture page. First, we need to go to the create event and create a uniform to pass over to the shader. So create event, create a uniform to pass data. Is the color overlay. shader, rainbow, test, yeah, whatever. Modify the draw event, get the values, and pass them to the shader. Nice draw event, shader set. So UNUV, shader get uniform, switch test, UUV, so that just pulls the variable UUV from the shader. Or rather creates it, doesn't matter, whatever, it does a thing. var UV gets a temporary variable, sprite get UVs, for sprite index and image index, which is get the, I think get the like, transparency and such. Set uniform F, UniUV, which I've got set, UV0, UV2. Now I don't... What's sprite get UVs? What does that do? The array returns an array with the UV coordinates and other data for the texture of the sprite sub-image on the texture page. Okay, you know what? I'm going to look up what a UV... What is it? UVs... UV coordinates and other data. Okay, so... UVs are two-dimensional data coordinate... or two-dimensional texture coordinates that correspond with vertex information for your geometry. There's an image here. On the Wikipedia page, in fact. Really not in good shape right now. Alright, so UV map, 3D model. So this is the UV map is like the shrunken texture map that gets wrapped around the sphere, and then the texture is the thing that actually goes onto it. I see, okay. So 0, left, top, right, bottom. Amount of pixels the asset palette is trimmed from the sprite's left side, right side, top side. Normalized percentage of pixel data from the original sprite's width has been saved to the texture page. Okay. Okay, so this is just the sub-sprite. So... in the case here, what this is getting is it's getting the left side and the right side. Is that... no, wait, is it top or left? Hold on. It's left and right. Okay. So it's getting the horizontal bit here, right there. Modify the draw event to get the values, then pass into the shader. Okay. Draw self, shader reset. The function sprite get UVs takes a sprite and an index and returns an array with tons of information, such as the coordinates for each corner, with how many pixels were cropped to optimize it, etc. We're interested in two of those values, left and right coordinates of the sprite, which are stored in UV0 and UV2. Fragment share will use those values to calculate the now normalized position like this. Fragment share varying, blah, blah, uniform vec to UV. I see. So that gets put in there. Yeah. UUV gets called in from the create event. UniUV. And this gets set to UniUV, which gets set over to here. UUV. Which gets sort of dragged down to... I'm not sure where exactly. Oh, right there. That's the position. Add the uniform variable at the top of the file, the same name we use in our create event. Next, check the normalized horizontal position by translating our current x coordinate to the origin. And we divide it by the width of the sprite to make the range from 0 to 1. Do whatever. The result is static rainbow. Which changes nothing for me because I was using a static image anyway. Every color of the spectrum inside our sprite. You might be happy with that, but we can have more fun with the shader. What if we had an offset to the colors based around time to produce movement? To do this, we'll need 2 extra variables for speed and time. Also need 2 more uniforms, 1 for each of the variables, so the create event becomes this. Alright. We also need to increase the time every frame, so the step event we add... Let's got this step event now. So what's the time thing here for? Oh, right, that's to move it. Step event we add, blah, blah. Let's go to the draw event, add these uniforms to the shader. Finally go back to our shader to actually use the variables now. So we'll do is multiply the speed with the time and add to the position, like so. I wish this thing showed me like what's changing. Instead of having to like just look at it and say, oh, that's what's changing. Okay. I Alright, so they got added there, and then time gets thrown in here. And now the shaders should be moving. There we go. Cool. There we go. All right. So, next step. Finish the shade around a few more uniforms to customize even further. The first two are control the saturation and brightness. The next one we'll call section. And its function is to allow the user to pass between 0 and 1 to determine what percentage of the entire spectrum we see at a time. Unless we have a variable called mix. Which will specify how much we want to mix our shader color with the original texture color. 1 is rainbow, 0 is all texture. So add these to the create event. Got it. All these things need to be. Okay. Okay, draw event changes. Okay, draw event changes. As for the shader, we need to pass the saturation and brightness to the color, which affect the color generated by the helper function. Section needs to be multiplied by our position to reduce the range. Also grab the entire texture color so we can calculate our color mixing the texture color with the RGB conversion of our color. Oh god. Okay, we're starting to get into parts I'm just reading and trying to work through like what it's doing, because this is a lot of mess. Shader, we need to pass the saturation. Okay, so in the create event, you create all these things. Basically, this just gets an ID that is going to be used later to apply a value to the shader. These are just variables being thrown in there. Draw event changes to include these uniforms like this. Okay, shader set. Everything gets applied to that shader. var UV is sprite get UVs. That's the position of the sprites, which is used right here. Sprite position gets pulled out. Set the UV stuff for the sprite there. Set the speed of it. Spend that, all that. Okay. Unit mix. Draw a self. Shader reset. As for the shader, we need to pass the saturation and brightness to the color, which will be effective, blah, 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 section, blah, blah, blah. Okay. So now it's for the fragment shader. Get all this stuff implemented in. All the stuff goes in. You got text chord V color. Okay. Uniform vec2 UV. Uniform float. So that just pulls in all these values and applies them. This is wrong. This applies all the values. Here, oh, this actually is a thing. Mix, val. What the hell is mix? Let's just do this. No, it's a mixed function. What the hell is this what the hell is mix? Okay, maybe it's part of like clamp. What's clamp? Number functions. Max. What the fuck is mix? What is mix? I've never heard of mix. Okay, so you do that, you just blah, blah, blah. Okay, void main, float. Final result is this. Yay! Oh, Christ. Oh, God. Okay. So this gives me a very basic idea of how texture stuff works with this. I'm just gonna turn that off for the moment. Actually, no, turn it back on. So now I need to go back to here. So what this thing does... Hold on a moment. Okay, sorry about that. I had to take a quick phone call. Anyway, so the thing I want to do now is like looking at this. The video was taking this stuff here where like pixels go across and it hits the overlay, which triggers part of the source. It triggers the map of the same color and pulls the source out. For access to source. Okay, let's just listen. I'm just gonna listen.
The final sprites. It reads every pixel in the source animation, finds its color on the map, and uses its UV coordinates to create the final image. As you can imagine, this whole process requires roughly the same amount of work as creating a separate set of animations. Except this time, we only need to do this once, and then we can change the character's appearance however we want. All in all, I think it's
Okay.
and the map to Unity. Here, a special asset importer produces the final sprites. It reads every pixel in the source animation, finds its color on the map, and uses its UV coordinates to create the final image.
So that's this is one part that's slightly off, because this is a actual Unity asset import thing, which I'd want to like potentially use this. I don't know, maybe do I don't know if you can do double shaders. So like my thought was basically do the same thing where you have the overlay here, right? This is your actual sprite that gets imported or whatever. You have your map, does the whole thing, imports it to the source. You know what? Let's go to... God, it's hot. Okay. Right, so idea is we have sprite messed up. into like the base form, which then gets shadered on and then produces the final sprite. Although this specifically might be a thing that I can skip a little bit, because if we do like a... this specifically only happens because you have the original sprite getting imported, right? Into Unity using the import program, which causes it to create like a secondary format, which is right here, which is the source. But that's only specifically happening because of the asset importer. If I actually just skip this step and like brought this one in by itself.
As you can imagine, this whole process requires roughly the same amount of work as creating a separate set of animations. Except this time, we only
like you can skip that entire step and just import this to here. And then just have that thing there. Like, the only thing you need to do is like have some sort of setup that would take your base and convert it into the overlay you need. Like, you would need the step here with this map. Like, this part here, and then just use this, skip this part.
Need to do this once. And then we can change it.
And then use this instead. Which should be doable. This would be like a secondary program, but also... I guess what it would actually be is it would be like a program that takes this in. I could probably write it in GameMaker, honestly. It takes the image, it basically applies a shader to it and spits it out as a sprite. I wonder if that's even possible. But you would take the image in, spit it out as a sprite with this overlay on it. And then... right, because what's happening here is this source image is actually using X and Y coordinates that are specifically pulled to here. And what I would do is like, so if I was making the program to do this bit right here, or rather it would probably be like, skip this part, just go from here to here, and then do this, because that's the way it would do it. I would probably do like, set this one up and then just do like color all the way down or whatever. And then, I don't know, like, I guess it's hard to say, right? It's hard to say exactly what the best way for this would be, because I don't really know shaders and all this stuff particularly well. Like, I could see like the sort of path towards it, but I'm not at that point yet. So, I don't know. Anyway, I'm gonna leave this as like a little experiment. I'm probably gonna actually revert this. Like, honestly, I haven't done anything of any real note. So I'm just gonna... revert to this revision. Yeah, so object test has changed, resolution, settings, menu button selector. There you go. Object test now no longer has any of that stuff in it. Everything still works as expected. That's going to be a much longer term thing. Let's put that in the to-do list. So shaders I kind of understand at this point, just like on a basic level. It's basically just making functions and then setting things up like that. So you figure out shaders. Specifically figure out the shaders needed to do this thing. Copy that over. Okay. All right. Oh, excuse me. I'm just gonna do this to clean things up a little bit. There we are. So now it's a little bit less messy. Make a winter screen at some point. Oh, jeez. All right. Man, I have no idea what to do here. And the heat's not helping. All right, so that's going to be a very long-term thing. What I probably should do is start cleaning up this to-do list. Get the winter screen, figure out about alphas and transparency and all that stuff. Fix settings up. Add get the resolution stuff. I'm gonna keep plugging away at resolution off screen. I think that's definitely something I need to do. Default settings one is actually pretty easy. All I need to do is just implement the default settings button. I just need to make it. Anyway, Alright, so that's what I'm gonna do. Shaders really, like, that whole thing just took a lot out of me, because the problem with shaders is that they're actually not too terrible to work with, but the documentation is awful. And it's a lot of, like, it basically is a whole other thing to just set up all these specific functions and variables. And what the fuck is mix? Like, all those things need to be set up in such a way that you just, like, ugh. It's a lot. And it's hot. I'm tired. Anyway, I'm gonna leave that there. Sorry if it was kind of a nothing. That was like a dream sequence of a stream where I just kind of did nothing and went nowhere with it. So, yeah. Alright. Anyway, I'm gonna leave that there for now. I'll be back next week with more of this, and we're gonna start just doing to-do stuff. I gotta finish up that to-do list. I've got things on there that have been sitting on there since day one. Day one. All right. Yeah, man. It's hard to think straight right now. That took a lot out of my brain just doing that, and doing all this stuff. Like, ugh. All right. So I'll be back tomorrow with Pathfinder Wrath of the Righteous. Maybe. I'm gonna be honest. If it's like super hot out tomorrow, I just might not. I might just like sit in a bathtub of cold water for the entire day, because the air conditioner is not working, and I just miserable. It's miserable here, and it's also humid. Like, what's the humidity outside? Let me check. In addition to being 80 something, it's actually not too humid out. It's supposed to drop overnight, but then also rain. It's not great. It's not great. And then next week we get back to 60, 80s. Yeah. I really hope everything's fixed by like Friday next week. That's when it's gonna get hot again. All right. Anyway, yeah. So that's where I'm gonna leave that. Thanks for stopping by. As usual, you've been listening to StreamBeats Lo-Fi playlist. It's not keeping me as chill as I would hope, but it's there. It's good times. And I'm just gonna pass out or something for a little bit. See you.